Today we are going to use our exponent rules in a new way, and that is to expand binomials that are of large powers with multiple variables going on. And we need to be able to do that in two different ways. We need to be able to expand binomials using both the binomial theorem and something called Pascal's triangle. In addition to that, we need to be able to find the coefficient of a specific term in a binomial expansion. So the binomial theorem is for when you are expanding a binomial raised to a power. So what you see here on the left side, a plus b to the n. So anytime you have two terms raised to a power, we can use the binomial theorem to expand it. Now for small powers, we may just want to FOIL it out, but you can see where you would want a formula if you had a plus b to the 8th power. You wouldn't want to FOIL that out 8 different times and in order to come up with the answer. So the binomial theorem is actually right here, and that looks super complicated because you've got symbols that you haven't seen. But what this symbol means, and we'll do a lot more with these later on in the year, but that's a summation sign, and it just means that you are going to add all of the different pieces of this together. So that giant, it's a sigma, the Greek sigma, but what looks kind of like an E is just telling you that you're going to add all the pieces together. So you can see addition between each of your terms. Notice there's a dot, 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 meaning that you continue on in this pattern until you get to the last term. Now, we're going to look at each of these pieces kind of separately, so then the formula hopefully won't look quite so scary. So the first part we're going to focus on is this, which says NCR, kind of. What that is, and you studied these, I believe, in Algebra 1, you did combinations and permutations. That means the number of possibilities that exist for choosing R objects of N. And the big difference between NCR and the other one you learned in Algebra 1, NPR, NPR is a permutation and CR is a combination. The big difference is whether or not order is important. And with combinations, the order is not important. So the number of possibilities, the order does not matter. So basically, what you're doing with a combination is you've got two subscripts here, the N and the R. The N represents the total number of items. So of N total items, you are choosing R of them. And all this combination is, in this formula, is the coefficient. Now, the N and the R are going to come from this formula here. N, notice, and that's the next question, what's the meaning of the value of M in the theorem above? If you look over on the left, N is the number of times the binomial is multiplied. It's the exponent. So it's the number of times that you're going to multiply the binomial. Now, we're going to look at the R's because there is no R on the left side, so it's a little bit harder to understand. But if you look, it says R equals 0 and then R equals N. And if you notice that all of the R's in the formula, so here's an R, here's an R, here's an R, notice that they're all the same. In the first term, this R is 0, that R was 0 because N minus 0 would be N, and this R is 0. Then notice in the next term, R is 1, R is 1, R is 1. Next term, R is 2, R is 2, r is 2. So do you see the pattern? What is happening with the r's? We're starting with 0 and we are doing what? Hopefully you notice that we are increasing. So the pattern is that we are increasing by ones, so we're just counting up 1 each time, from 0 to, look at where it stops. We stop when r gets to being equal to n. So we start at 0 and we keep counting up with r's until we get to whatever the value of n is. So if you're finding a binomial to the 6th power, that means you keep increasing your r's until you get to 6. If you're finding a 7th power, you keep increasing till you get to 7. All right, let's look at another pattern here, the exponents of the a. So if you look here, here's an exponent of the first a, it's n. Then n minus 1, then n minus 2, continuing in the pattern until we get to 0. So what's happening there is just the opposite of what was happening in the others, and that is that here we are decreasing. So we started at n, and we keep going down 1 because n minus 1, n minus 2. So we're decreasing by ones from n, that's our starting point, down to 0. Then let's look at the exponent of b. b was 0, then it was 1, then it was 2, until it gets to n. So that one is the exact same as what we had with r. So that one is also increasing by ones from 0 to n. All right, I'm sure this still looks a little bit scary. So the best way to make it not scary is to try to apply it to one of our problems so that you can see how these patterns work. It's really important. You're going to be given the binomial theorem. You're never going to have to memorize this. But if you don't know the meaning of the terms and you don't know these patterns, being given the formula isn't going to help you because you're not going to know what to do with it. So it's really important that you know these patterns, what happens with the r's, what happens with the exponents of a, what happens with the exponents of b. So if we look here, the first thing that you should do is identify your a, your b, and your n. So n is the exponent. So in this case, n is 4. My a, my first term, is x, and my b, my second term, is 3. So I'm going to apply this formula, and remember, this is the formula right here, but what's to the right after this equals is what you're actually going to be writing out. So the very beginning, we have n choose 0, so n is 4, so 4 choose 0, then we have a to the n, a is x, so x to the n, which is 4, b to the 0. Oops, and I forgot to plug in my b value, silly me. So that's 3 to the 0. Notice the plus sign, it's a summation, so plus. Now we go to the next term. Remember, the subscripts of the combinations, they increase by ones from 0 to n, so this is going to go up. The patterns on the exponents of a of my first term is going to go down. So next, I'm going on my combination, instead of 4 choose 0, I have 4 choose 1. Now this exponent is going to go down, so instead of x to the 4th, we've got x cubed. My exponent on my 3 is going to go up as well. Next, 4 choose 2. This increases, the middle decreases, so x squared, and the other end increases. Plus, again, first term and third term are going to increase. So 4 choose 3. Middle term decreases. So down to 1. And then this one also increases. Remember, these should match. Then we've got 4 choose 4, x to the 0, 3 to the 4th. You know that you're done when the n and the r match and your middle one has an exponent of 0. So this is what the binomial theorem says is what we should get when we take x plus 3 to the 4th power. Now this one we could check. You could FOIL x plus 3 times x plus 3 and then FOIL that answer with itself. But we can simplify here, and you probably should know how to do that in your calculator because a combination is something that you learned to press in on a calculator. 4 choose 0. How you press that in is you're going to type the 4, then you are going to hit math. When you hit the math key, remember there's a whole menu at the top. You're going to scroll over until you're on the PRB. That stands for probability. So use your right arrow key to scroll over till the PRB is highlighted. And then you should see in your menu choice 3, which is NCR. So choose number 3. It should go back to your home screen and you should see already 4. NCR, and now you tell it 0. So this is what you see after you choose 3. Then you need to press in the right side, so how many you're choosing, and then press enter. So 4 choose 0 we find out is 1. So this is 1, x to the 4th, 3 to the 0 is 1. So that's easy to simplify. Over here, you're going to follow the same steps here to find out what 4 choose 1 is. So 4, then hit math, scroll to probability, choose choice 3, and tell it to choose 1 of those 4. Press enter. You'll find that that is 4. So 4 times x cubed times 3 plus 4 choose 2. So same steps, 4, math, probability, choice 3, and then put in your 2. You should get 6 as your 4 choose 2. So 6 times x squared times 3 squared, which is 9. Over here, 4 choose 3. Hopefully you've got the hang of pressing these combinations in. You'll press the 4, then math, scroll to probability, choose choice 3, and then in this case, 3 is what you'll enter instead of the 0, and then hit enter. 4 choose 3 is 4 times x times 3 to the 3rd, which is 27. And then finally, 4 choose 4 is 1, x to the 0 is 1, and 3 to the 4th is 81. So now, my final step of simplification here, combine these, that just gives me x to the 4th. Multiply those, that's 12x cubed. These, 6 times 9 is 54, so 54x squared. 4 times 27 is 108, so 108x. And then 1 times 81 is just 81. So then this is your final answer. And again, you could check that since this is a relatively small number. You can FOIL x plus 3 times x plus 3 and then take that result and FOIL it with itself. All right, let's try another of these. So now I've got 2x minus y squared all raised to the 3rd power. So in this case, my n is 3. My a, my first term, is 2x. And my b is negative y squared. Make sure we take the negative symbol with it if it is negative. So, to start this problem, I'm going to draw a little line here to separate these. So first I start out with my combination. So my n is 3, so it's going to be 3, choose 0. My a value, my first term there, needs parentheses because it's the whole thing raised to that power. So starts at 3. Then my second part also need parentheses, negative y squared, and that starts out at 0. Again, remember the middle term starts high, the other two start low. So then add and continue the pattern. Everything else is going to stay the same. This number is going to increase, this 0 is going to go up, this one's going to decrease, this one's going to increase. So if I want to start it out, I know it's going to look something like this, and I can just fill in the numbers as I go. So I started at 0, this becomes a 1. This started at 3, so this becomes a 2. This started at 0, so that becomes a 1. And then do it again. So this should be increasing, 0, 1, now 2. This should be decreasing. It was 3, then 2, so now it should be 1. And this should be increasing, squared. And then I wrote too big here, so I'm going to write it down here. 3, choose 3, 2x to the 0, negative y squared to the third. So now I'm going to simplify. Again, you should hopefully now know how to punch a combination into your calculator, and you'll notice a pattern. Anytime you're choosing 0 or choosing the same number, it's going to be a 1. So this is going to be 1 times this. You need to use exponent rules. 2 cubed is 8, so that's 8x cubed. Here, anything to the 0 power is 1, so I've got that. Over here, I've got 3 choose 1, which is just 3, times 2 squared is 4, so 4x squared, and then times negative y squared. Over here, 3 choose 2 is also 3. 2x to the first is just 2x. When I square this, be careful, you have to square both terms. The negative squared is going to give you a positive, and then the y squared squared is going to give you y to the fourth. So it's positive 1 y to the fourth. And then my final term down here, 3 choose 3, is 1. Anything to the 0 is 1. Again, this negative y squared, you have to cube the negative 1 also. So that's going to be negative, and then it's going to be y to the 6th. So final simplification here, multiply those together, that gives me 8x cubed. Multiply these together, be careful of the negative. 3 times 4 times negative 1 gives me a negative 12, and then that's x squared y squared. Don't combine these bases that aren't alike. Here, 3 times 2 times 1 is 6. So 6x y to the fourth. And then over here, again, careful of this sign. That's a minus 1 and then y to the 6th. Notice the pattern that happens with your signs, and this is always going to be true when it's a minus sign between. So this is a good way to check your answer, to check your work. The signs should rotate. If this is a negative in there, it should be positive, negative, positive, negative, positive, negative, positive, negative, so on and so forth. All right. Example 2, find the coefficient of x to the 7th in 2 minus 3x to the 10th. Notice it doesn't ask you to expand it, it just needs you to use the patterns to find one particular term. So the formula that looks like this, if it wants you to find the coefficient of x to the 7th, your x is part of your b term. So if it wants to find the coefficient of x to the 7th, it's wanting you to find when r is 7. So that should be relatively easy to do because you know that r counts up. So whatever r is, if you want to know when r is 7, plug that number in for r here. You know what n is. N is 10. So we can plug that in here. So if n is 10, we're going to go 10, combination, and we're choosing 7 because, again, it's coefficient of x to the 7th. So my a value is 2, n minus r. So 10 minus 7. My b value is negative 3x to the r, which is 7. And now I just need to simplify that single term. You do not have to expand it all when you're just finding a single coefficient. So 10 choose 7 is going to give you 120. Then 10 minus 7 is 3, so 2 cubed is 8. And then here I have to take both of these to the 7th power. Negative 3 to the 7th is negative 2,187. And of course, x to the 7th is just x to the 7th. So now, all it wants is the coefficient of x to the 7th. So it means all I care about is the numbers. So 120 times 8 times negative 2,187 is negative 2,099,520. So again, don't expand the whole thing. That's way too much work. It's telling you what n is here. It's telling you what r is here. And it tells you what part you want when it says the coefficient. So don't make that more complicated than it is. All right, I'm sure all of you very greatly dislike the binomial theorem by now. Hopefully you will like Pascal's triangle a little more because it's a shortcut, kind of, for the binomial theorem. What it is it's an arrangement of the values of the combination of n choose r in a triangular pattern. So if you actually worked out all of these combinations that are here, it would start out with 1, and then this is also 1. 1 choose 0. 1 choose 1 is also 1. 2 choose 0 is 1. 2 choose 1 is 2. 2 choose 2 is 1. 3 choose 0 is 1. 3 choose 1 is 3. 3 choose 2 is 3. 3 choose 3 is 1. Last one that's here. 4 choose 0 is 1. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. I'm sure maybe you are wondering how I knew what all those combinations were off the top of my head, or maybe you just assumed I'm looking at a key to know it. But the way that you actually get the Pascal's triangle numbers is by adding what's above. So anytime you have two numbers next to each other, it trickles down. You add those two together to get the next one. Now the edges are always ones. So these two are how I got the 3. These two got me that 3. These gave me the 4. 3 plus 3 gave me the 6. 3 plus 1 gave me the 4. So what you should do now, pause it and do the next rows without typing in any combinations. So just use this pattern to fill out the next 2 rows of your Pascal's triangle. So you know that the edge is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And the edge is always 1. The next one, edge is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And the edge is 1. You can continue this Pascal's triangle on and on and on and on and on. But the way that we are going to use Pascal's triangle is whatever power it's raised to, you go n exponent uses the n plus first row for the coefficients. So basically, instead of having to use the pattern for the combinations, you can just use the row to come up with the coefficients. Now, you're still going to have to know the patterns on the A and the B. So remember that the middle term, the A term, starts out at n and goes down, and the other B term starts out at 0 and goes up. So we're going to use Pascal's triangle to write the binomial expansion of x squared plus 3y raised to the 5th power. So since this is the 5th power, that means we are going to look at the 6th row. So the 6th row of Pascal's triangle, 1, 2, 3, 4, 5, 6. There is the 6th row, so instead of doing combinations as the first part, because there's always 3 parts, so we're going to have the coefficient, and then we're going to have the a to the n term, and then we're going to have the b to the 0 term. Remember that this one decreases, and this one is going to increase. So we start off, my first coefficient is 1. So 1 times my a term, which is x squared, to the high power, so it starts out at 5, times my b term, which is 3y, to the 0. So that's my first term, plus. Then the next coefficient in the row is a 5. My a term, x squared. Now this is going to decrease. My 3y power is going to increase. So I used the 1, I used the 5, now I'm going to use the 10. So plus 10, and then x squared, I'm decreasing by 1, so this goes to 3. This increases by 1, it goes to 2. Now use the next 10, so plus 10, x squared, we're decreasing still, down 1 more to 2. This one's increasing to 3. Now use the 5. So x squared is now to the 1st, the 3y is now to the 4th, and my last one, of course I always write too big, I'll just have to put down here, plus 1, and then x squared to the 0, 3y to the 5th. So again, the coefficients here were at the beginning of each, 1, 5, 10, 10, 5, 1. The middle and the end, you do the exact same thing as with the binomial theorem. So now I just need to simplify. So exponent rules here, that gives me x to the 10th. This is obviously 1. This is 1. Over here, I've got 5 times x to the 8th times 3y. Over here, 10 times x to the 6th times 9y squared. This one, 10 times x to the 4th times 3 cubed is 27, so 27y cubed. This one, darn, running out of room. So this one is coming down here. 5 times x squared times 3 to the 4th power is 81, so it's 81y to the 4th. And then finally, this one down here, 1 times x squared raised to the 0 is 1. Then 3 to the 5th power is 243. So 243. And then y to the 5th. So now I need to simplify again. So I've got x to the 10th plus 15 x to the 8th y plus 90 x to the 6th y squared. And over here, let's see, I've got 270 x to the 4th y cubed. Over here, 5 times 81 on the coefficients, which is 405. So 405, and then I've got x squared y to the 4th. And then finally, I'm going to write it right above from this. That's just my 243 y to the 5th. And that lovely thing is my answer.